Next speaker is Dr. Yuji Inoue from Toyota Infotechnology Center Incorporated, who is speaking on connected cars and automobiles as the infrastructure. At Toyota, he serves as the chairman and CEO of this subsidiary, which is responsible for research on ICT technologies as related to automobiles. In the era of ITS, intelligent transport system, every car has some sort of communication devices enabling not only a maneuver-related system, but also social life-related applications that are emerging. And since Dr. Inoue was previously the head of the research laboratory of NTT, which is the largest telecom carrier in Japan, and actually he was the head of the 6,000 researchers, $3 billion budget that the government sort of admitted. And so we believe that his concept for the state of the future communications for all things related to automobiles should be really truly inspired. So please welcome Dr. Yuji Inoue. Okay.
Hi, good morning, ladies and gentlemen. This is my great pleasure to be here, and this is my first time to attend the PTC. Although the name I was known for a long years because I was an engineer as Sakamaki-san introduced me, but since the name of Hawaii, sometimes they hesitated us to attend here. But anyway, it's my great pleasure to be here again. And today, since I moved to the automobile ICT, information communication technology area 4 years ago, since then I have been working how to the car be connected. Not for the safetiness of the so-called ITS, intelligent transport systems, but how to use the car as a new infrastructures, as I would like to explain you now. Okay, you know, the 1 year has the 8,000 hours. How many hours you are using your car is like this. This is the United States statistics. So in Japan, I guess that it's 500 hours or something like that. That means you are using only car as a moving vehicle about the 10% or less than 10% of the total year. Other hours, you put cars in the parking slot. And then if you turn off your car, it's just a damn iron box right now. But you see here, in the case of the Toyota Prius, it has more than 4 kilowatt-hour battery. So even if we turn off the car, batteries are quite enough in capacity. So how to use that one for various purposes? Okay, so I introduced the buzzword O 2.0. It's similar to the Web 2.0, as you are very familiar with that. And then I'm aiming to introduce a new infrastructure for the smart and resilient society. Okay, let me explain you how to use a car in the disaster cases. So as an example of the resilience, you see here, this happened 4 years ago in Japan. As you know that the big earthquake hit the east part of Japan, and lots of tsunamis and huge damages happened. You see here, okay. Here, the grounds are damaged like this. But at the time, also the car was running in that damaged field. And what happened at that age, due to that experience, that I'm now proposing to use the vehicle as information hubs, together with the temporary shelter and the electric power sources. how to do it, and why do we need this kind of things. This is when the cities are attacked, many people died, over 5,000 people died, but still most of them alive. And their houses are broken, so they had to go into the evacuation sites or refugees. In Sendai City, it had more than 300 refugee places or the evacuation sites. And since that happened during the daytime, suppose that the wife who is working as a part-timer in a supermarket, etc., and his husband is working in another place, and the children were going into the school. So families are split and had to be in the different evacuation sites. How to find their family members? It was very, very hard things because all of the telecommunications infrastructures were gone, destroyed within about a week. So how they did it? Like this, paper patch, or writing the messages on blackboard or whiteboard. And in the case of the paper patch, who distributed these papers to different the evacuation sites? Car with a gasoline, the hand patched. By seeing these figures, I thought, if the car distribute the paper, instead of distribute the paper, but instead distributing the message electrically. So then, car has this is the current car's phenomenon, the capability. But if we could equip Wi-Fi in the car, Wi-Fi is everywhere except car. Why? And in addition to that, there's a cognitive radio or white space, which has more capacity and capability for the distance. And plus the UHF ITS. ITS stands for the Intelligent Transport Systems. Mainly that is designed for the vehicle-to-vehicle communications and vehicle-to-traffic signals communications for giving more safety to the car. And also, the car can be used as I mentioned, it's a shelter. Here you see, this is not the door, but this is real dog as a pet. In the evacuation site, the people cannot bring their cats or dogs in that area because some people don't like that. So cars are used as a shelter of the pets. So also this is the different importance of the car. Okay, so at the occasion of the ITS 2013, 1.5 years ago, we had the ITS World Congress in Tokyo site. So then I demonstrated as a real scenario for how to use the cars in this situation. So as you see here, all of the mobile base stations are gone. But if you could have the car Wi-Fi, people can connect to the car through the mobile phone. Right now, more than half people are carrying the smartphone. The smartphone has the messaging capabilities through the Wi-Fi. Messaging not only the letter, but also by voice. And cars are moving around, so this message can be transferred by cars and then to one evacuation site. And if in one evacuation site, some car, like a local city car, has the capability of the cognitive radio or white Wi-Fi, white space bands, then by using this capability, this site can be connected to other sites. And among the 300, if one car or one evacuation site has the electrical power and be connected to the satellite, for example, as the internet capability, then these areas, all of the necessary informations are uploaded to the internet or downloaded from the internet. So within 1 week, when all of the communications tools are gone, car will use as only one or the most important communication tool in this damaged area. That is very important to make the families finding, et cetera, et cetera. Okay? And one thing I illustrated in there that ITS, what ITS will be used in these disaster cases. This is the current situation when the big disaster happens and lots of buildings and houses are broken. We have to find out the people, victims under that the broken buildings. Right now, only the way is, as you see here, dog. To use the dog's nose. The dog nose sensitivity is more than 10 times than the people. So this is the only way. And if you, we have to find out the bodies buried under the ground, the disaster cases. So only thing we are now using is the rod. You see somewhere here, finding out the people, because we can take out this kind of garbages by machine, because the bodies might be buried there. So this takes a lot of time. But in the case of the victims under the buildings, usually we have to rescue them within 2 days. Otherwise, even if they are arriving alive, their life might be lost. So what we are now considering is that to prepare the wearable vehicle to H stands for the human. So this is a wearable chip. We are now designing this mainly for protecting people or pedestrian by the attack of the car. But why not extend its capability to these situations? So we are now developing this size of the chip or the equipment, which can be installed anywhere inside of the shoes or inside of your belt or whatever you like. So then if the people wears these things, and we are now designing it, it's the radio radiation capability about 1 month. So then, of course, we can use a dog, but in addition to the dog, we can find by the handy probe or by cars or even by helicopter. Our simulations gives us that about 300 meters over the air, we'll be able to get the radiation from this very small chip. Okay? So as TTC is a Japanese standard organizations. TTC last August proposed this idea to the ASTAP. ASTAP is the Asian standards. And not only the technology, but also how to use these the disaster machines into the society, because how to use it and how to using it with the standardization is very important, because the Japanese people or Japanese guy may visit there to Philippines, for example, and then help them. So if the machines are different and the usage of the machines is different, it's very, very difficult to split this kind of technology for the real usage. So together with the technologies and the usage, we propose the standardization of these technologies. One is Wi-Fi, how to use the Wi-Fi, and UHF-1, the intelligent transport systems, and white space, or in other words, the cognitive radio. And we started this, and within 3 years, we are hoping that this could be standardized. Okay, so another topic is that how to use a car in the mining. You see here, this is one example of the Chilean, the biggest mining area. And in a normal road or tunnel, you see the car, about 2 ton to 4 ton plus the trucks, the both way capability. And then the total length of this tunnel right now, over 100 years, it gets over 6,000 kilometers, not 6,000 meters. So, but since they have been, the miner have to maintain this over 6,000 kilometers tunnel, how to do it? They are doing it, of course, but you can imagine how difficult to keep the 6,000 length network, since you are the telecom, the background. So I'm now proposing, now Chile started to dig the 4 to 5 new mining. So I'm proposing them that to equip the car hub, which can connect these kind of the sensors. In another word, it's IoT, Internet of Things, or Internet of Everything, or machine to machine. And this server could make the neighborhood area network plus information processing as the first order of the processing. And these networks, since this is a neighboring area, so many cars are running in this area. So where? There are many these neighboring areas networks. They're composed by the car, and finally this will be connected to the backbone optical networks with the capability. So then this will ease the maintenance, and also gives much more power in the processing. And this is the wearable, the worker's clothes. This was, by the way, I'm the visiting professor of the University of Chile, and my member, they created this idea and made a demonstration unit, and then proposed to the Intel's global challenge. And we got worldwide #1, the prize from the Intel. So this is a worker's jacket, including the sensors of like heartbeat. So then workers have some the injury situation or in sick. This could be reported to the car automatically and processed in the car hub, and then reported immediately to the center controlling stations. By the way, in the mining area, always over the 2,000 workers are working there. So you can imagine that how the importance will be this kind of the jacket. Okay, now the time is going on, so I'd like to skip some few slides more. And this is the total architecture of the smart and resilient society with the car, like this. So as I mentioned here, that integrated by the ICT, partially the volunteering by the vehicle. So I am not, let's say, competing with the telecommunication at all. car will provide such kind of the very small area of network with the processing power, and how to do it together with the telecommunication capability. That's our challenge, and I'm looking forward to cooperate with the telecom guys in this area. Thank you very much.